All right, get ready because today we're diving deep into quantum computing. Specifically,
Yeah.
Google's new Willow chip.
Okay.
Imagine a calculation so complex that it'd take a supercomputer 10 septillion years.
Wow.
Longer than the universe has existed. But Willow just did it, and we're going
Right.
to break down just how it was able to do that.
Yeah, it's pretty remarkable. And it really comes down to Google tackling one of
Yeah.
the biggest hurdles in quantum computing, and that is errors. They published this blog
Mm-hmm.
post Meet Willow, our state-of-the-art quantum chip, where they sort of detail all of their
Nice.
achievements.
Okay, so I remember reading about quantum computers, and you know how they're prone to errors because those qubits are super
Mhm.
sensitive? But what is so different
Right.
about this?
What's exciting is that they've reached something called below threshold error correction
Mm.
with Willow. This is something that researchers have been struggling with for almost 30 years. Essentially, Willow is designed in such a way that as you increase the number of qubits, the error rate actually goes down.
So it's not just about adding more qubits, it's about making sure they work together.
Exactly.
Reliably, right.
Right.
But how do we know for sure that this error correction is actually working?
Well, that's where this 10 septillion year calculation comes in.
Right.
It's not just a catchy headline. It's the result of Willow completing this benchmark
Yeah.
called random circuit sampling, or RCS.
Okay.
And to put that into perspective, if you had every computer on Earth
Wow.
working together for billions of years,
Wow.
they still wouldn't come close to what Willow was able to do with this task.
That's some serious computational power. But I'm still a little fuzzy on why this RCS thing is so important. It's not just about speed, is it?
No, you're absolutely right. RCS is really designed to prove that quantum computers are doing something fundamentally
Okay.
different from classical computers. Some physicists even suggest that this type of computation might be happening across multiple universes,
Whoa.
like David Deutsch has theorized, but that's a
Wow.
whole other deep dive trope.
Okay. Save that for another day. So Willow is error corrected, crazy fast, and potentially tapping into multiple universes.
Yeah.
What does that mean for us?
So that's the next
The real world.
big question.
Mhm.
While benchmarks are important, the true potential lies in solving real-world problems. Right?
Yeah.
So imagine using Willow to design new materials for more efficient batteries, or even simulating
Okay, yeah.
complex molecules for drug discovery.
Right.
Problems that today are just impossible for even those powerful supercomputers.
Okay, so we're talking personalized medicine, next generation energy solutions.
Absolutely.
But how does Willow achieve all of this? What's going on
Well, so the blog post really
under the hood?
highlights the importance of their state-of-the-art fabrication facility in Santa Barbara and their focus on systems engineering. They're not just throwing more qubits at a problem. They're really
Right.
focused on the quality and how those qubits interact.
So quality over quantity when it comes to qubits. Makes sense. Can you give us some specifics
Yeah.
on what makes Willow so special?
Sure. One key metric is something called T1 time.
Okay.
And essentially, this measures how long qubits can hold their quantum state. Essentially, how long they can avoid those pesky errors.
Gotcha.
Willow has seen a 5-fold increase in these T1 times compared to previous chips,
Wow.
which really contributes to its stability and performance.
So longer T1 times, fewer errors, more reliable quantum computer.
Exactly.
Big win. I'm curious about something else I've been hearing a lot of buzz about, and that is quantum AI.
Yeah.
What's the connection there?
Well, that's where things get really interesting.
Yeah.
Hartmut Nevin, the founder of Google Quantum AI,
Uh,
believes that quantum computing will be essential for
wow.
major advancements in AI. Just imagine, quantum algorithms analyzing enormous data sets that are beyond the reach of classical computing.
Right. So instead of just crunching numbers, quantum AI could help computers understand and respond to human language with
Yeah.
all its nuances.
Yeah, this could completely revolutionize how we interact with technology.
Yeah.
Absolutely. And this
Yeah.
is just the beginning. There's so much more to unpack about this.
Right.
But I think maybe we save that for the next part of our deep dive. What do you think?
Let's do it. This is some mind-blowing stuff. We'll be back in a flash to delve deeper into the future of AI with quantum computing.
Welcome back to our deep dive into Google's Quantum Leap with Willow.
We left off talking about the potential for quantum AI and how it could completely change how we even think about artificial intelligence.
Yeah, this convergence is really generating a lot of excitement, and
Right.
there are good reasons for that.
Can you break down some of the ways that quantum algorithms might lead to better AI systems?
Sure. One of the biggest limitations for even the most advanced AI today
Mm.
is just the sheer amount of data
Right.
that they can handle.
Yeah.
But with a quantum computer, you could analyze data sets that are exponentially larger and more complex
Right.
than anything we can even imagine processing right now.
It's almost like giving AI a whole new dimension of understanding, right? Allowing them to find connections
Yeah.
and patterns that would be completely invisible to us.
That's a great way to put it. Think about fields like natural language processing,
Yeah.
where we're trying to teach machines to truly understand human language or even scientific discovery, where
Right.
an AI
Oh,
could
right.
analyze massive amounts of data and make connections that would take humans
Wow.
years or even decades to uncover.
It sounds like we're talking about a whole different level of cognitive ability
Yeah,
for AI.
exactly. And beyond just analyzing data, quantum computing could revolutionize how we train and optimize
Okay.
AI models themselves.
So this is the part where we get closer to things like self-driving cars and other AI applications
Right.
that need to make decisions in real time.
Absolutely. Some quantum algorithms are specifically designed to speed up that training process for these
Oh.
machine learning models. So potentially we could see much faster development and more efficient AI systems.
The possibilities for real-world applications are really exciting.
Absolutely.
We touched on this earlier, but I want to go back to the idea of simulating complex systems.
Sure.
Why is that so important for the development of AI?
Well, one of the ultimate goals of AI is to create systems that can interact with the real world in a
Right.
meaningful way.
Yeah.
But the real world is messy, full of countless variables and interconnected systems that are just extremely difficult to simulate accurately
Yeah.
with classical computers.
So a quantum computer could be like a supercharged simulator,
Yeah.
giving AI a much more realistic training ground to
Yeah.
learn and adapt.
Precisely. Imagine being able to simulate something as complex as the human brain or the financial markets
Right.
with a high degree of accuracy. The insights we could gain would be invaluable
Yeah.
for developing truly intelligent systems.
This all sounds incredible, but I think it's important to acknowledge that we're still in those early stages
course.
here.
Yeah.
There must be some serious challenges to overcome before this becomes a reality.
Yeah, we're just scratching the surface of what's possible with quantum computing.
Right.
You know, as the blog post mentioned, the next big challenge is to demonstrate a useful, beyond classical computation.
Okay.
So something that can be solved more efficiently on a quantum computer than any classical computer.
So it's not just about theoretical benchmarks anymore. It's about
Exactly.
finding real-world problems where quantum computing has a clear advantage.
Exactly.
Hmm.
And Google is actively collaborating with researchers in various fields to identify those use cases and develop the necessary quantum algorithms. They're also taking steps to make this technology more accessible through open sourcing software and educational resources like their Coursera course.
It's encouraging to see them thinking about the practical side of things and
Absolutely.
making sure that this technology benefits society as a whole.
Absolutely. And it's important to remember that Google isn't the only one working on this.
Right.
There are other companies and research institutions all over the world that are exploring different
Yeah.
approaches.
So it's a little bit like the Wild West out there with different
Yeah.
ideas and technologies competing for dominance.
And it's still too early to say which approach will ultimately be the most successful.
Yeah.
But this competition is driving innovation at a breakneck pace,
Right.
which is incredibly exciting.
I have to admit, even with our deep dive, I'm feeling a bit overwhelmed by all the possibilities
Yeah.
and implications of quantum computing.
It's definitely a lot to process.
Yeah.
But that's part of what makes this field so fascinating, right?
Right.
We're witnessing a technological revolution in real time.
And it's not just about the technology itself. We're starting to grapple with
Right.
those philosophical implications of what it means to have access to this kind of computational power.
That's a great point.
Yeah.
Perhaps we should delve into those deeper questions
Yeah.
in the last part of our deep dive.
I think our listeners could use a moment to catch their breath
A wise decision.
before we venture into the philosophical realm.
We'll be back shortly to explore the even bigger questions raised by Google's quantum leap.
Welcome back. I don't know about you, but my head is still spinning from all this talk about quantum AI and the amazing potential of this Willow chip.
It's a lot to wrap your head around, but even beyond those practical applications,
Right.
this technology is pushing us to think differently about the universe and
Yeah.
our place in it.
That's what I'm really curious about. We've talked about the how of quantum computing. What about the why? What are the deeper implications of this technology? The philosophical questions that it raises?
Quantum mechanics itself is just inherently mind-bending.
Yeah.
Concepts like superposition, where a particle can be in multiple states at once,
Right.
and entanglement, where particles are linked across vast distances. These ideas
Right.
challenge our everyday understanding of reality.
It's like the universe is operating on this set of rules that we're only just beginning to understand.
Yeah.
And if quantum computers are tapping into those rules, what does that even say about the limits of
Oh.
our current understanding of the world?
Well, some physicists, like David Deutsch, believe that quantum mechanics supports
Okay.
this idea of a multiverse,
Oh, wow.
where
Yeah.
countless parallel universes exist alongside our own.
Multiple universes. That sounds like something straight out of science fiction.
Yeah, it's a pretty wild concept.
But I can see how the idea of a qubit existing in those multiple states simultaneously
Right.
might open the door to that kind of thinking.
Yeah, it definitely stretches the imagination.
Yeah.
But even if we set aside the multiverse theory, the fact that these quantum computers can perform these calculations
Right.
that are impossible for classical computers raises these really profound questions
Yeah.
about knowledge and what we can ultimately know.
If there are problems that are simply beyond the reach of our current technology, does that mean there are limits to human understanding?
Hmm.
Or are we just using the wrong tools?
That's a fascinating question.
Yeah.
Perhaps there are entire realms of knowledge that are only accessible
Wow.
through this lens of quantum computing.
Okay.
We might need to redefine what we consider knowable.
It's like we're standing at the edge of this new continent with vast uncharted territories waiting to be explored.
Yeah,
And Willow is one of the first ships to set sail.
I like that analogy.
Yeah.
It really captures that sense of excitement and potential surrounding this whole field.
Right.
And it reminds us that scientific progress isn't just about practical applications.
Mhm.
It's about expanding those boundaries of human knowledge
Yeah.
and our understanding of the universe.
Well said. So as we wrap up our deep dive into Google's Quantum Leap,
Yeah.
what's the one thing you hope our listeners will take away from this conversation?
I think the most important takeaway is this. If quantum computing can solve problems
Yeah.
that are currently impossible, what kind of future could we create?
Right.
What discoveries await us?
Yeah.
What limitations can we transcend? These are the questions that I find the most inspiring,
Yeah.
and I hope they spark our listeners' imaginations as well.
Absolutely. It's a call to action for all of us to learn more,
Yeah.
explore further, and imagine the unimaginable.
Right.
And who knows, maybe one of our listeners will be the one to unlock the next big quantum breakthrough.
That would be incredible, and it's a possibility that we shouldn't underestimate.
Yeah.
The future of quantum computing is wide open,
Right.
and it's going to be an amazing journey to watch unfold.
Thanks for joining us on this deep dive into the world of quantum computing.
It's been a pleasure.
We'll see you next time for another fascinating exploration.